The topic of our Magic of Material project is the world of lasers. Optical tweezers are scientific instruments that use a highly focused laser beam to provide an attractive or repulsive force to physically hold and move microscopic objects similar to regular tweezers. They're able to trap and manipulate small particles, including dielectric and absorbing particles. They have been particularly successful in studying a variety of biological systems in recent years. In 1986, at his Bell Labs in New Jersey, Dr. Art Askin noticed that some of the particles in his sample began to stick to the laser beam and follow it around. The laser beam squeezed the focus, holding it stationary while the rest of the sample moved around it. Due to their ability to precisely manipulate microscopic particles, laser tweezers are used in a variety of applications in experimental physics, biology, and chemistry. Objects that are smaller than 10 microns can be trapped and moved about. Also, because of the shape of the potential energy well, it is possible to measure forces in the order of piconewtons. A microscope objective lens and laser pointer of a few milliwatts is all that is required to capture and manipulate micrometer-sized glass or plastic beads suspended in water. Optical tweezers work by arranging the direction and intensity of incoming beams of light so that the object is held fixed in 3 dimensions. A single protein molecule is tethered between 2 beads using DNA as molecular handles. One bead is the optical trap, and the other bead is held by suction on the tip of a micropipette. The target protein is mechanically unfolded and refolded by moving the bead in the optical trap away or toward the bead in the micropipette. Due to advances in diode laser technology, it is now possible to access powerful lasers in a variety of wavelengths at lower cost than ever before. The laser tweezers are a useful tool for biophysicists who wish to measure the minuscule forces exerted by the cellular interactions in vivo, an important area of current research. With the availability of a large variety of protein-coated polystyrene beads, researchers are able to probe interactions between the cell and its external environment using this very flexible experimental technique.
The composition of the optical tweezers has not been changed since it was created. It uses a commercial optical microscope and can add extensive modifications in order to customize the instrument. All the materials that are included are always for the benefit of the operation of the tweezers. As you can see, there are many materials that are included in the creation of the optical tweezers. This is a scanning electron microscope picture of what a laser looks like. The word laser is originated as an acronym for light amplification by stimulated emission of radiation. The first laser was built in 1960 by Theodore H. Myman at the Hughes Research Laboratories in California based on theoretical work done by Charles Harthound and Arthur Leonard Shallow. The base material of a laser is the substrate. On the substrate, other materials will be deposited. A wafer of the substrate is produced, cleaned, and prepared. The substrate will go through several steps where layers of material will be deposited on it. These layers can be only several atoms thick. The layers can also be conductive, using metals such as aluminum or gold, or can be semiconductors. Layers can also be altered by exposure to other chemicals. After all the materials have been added onto the substrate, the wafer is diced and cut into individual laser diodes. Lasers are used in everyday life in objects such as laser printers, laser hair removal, laser tattoo removals, and as laser pointers. They can also be used in societies such as X-rays. These have a commercial and economic impact on society. X-rays allow clear view of bones without having to open up a person to see. Lasers have an economic impact which allow for a new market of laser hair removal and tattoo removal.